So let's look at an example with customer records for this locality sensitive hashing. So the idea is to examine collection of records and determine if they refer to the same entity. In this case, if they refer to the same customer. It could be, if we're looking at customers, it could be people, events, cars, or some description of other objects. So if we want to merge records, if their values in the corresponding fields are similar. Now, if we're going to use customer records, let's say some company collected information about their customers, and another company wants to get information and just pay a fee to get to that information. And then they have some issue that they cannot determine how many customers are involved. So company A wants to get the customers from company B. Then they argued about how many of those customers they will get information for, and finally they couldn't remember how many customers are involved in this issue. So each company has 1 million records describing the customers that have been sent from the one company to the other. And so the things that are recorded, so this will be these descriptions here that we looked at: the name, first row, address, second row, phone number, third row, and other descriptions of these customers. So we will be just comparing the properties of the descriptions of these customers. So the first thing we want to do is to design some measure of how similar the records are. They could have some mistakes in them, so we can try to accommodate for those mistakes into our measure. They could be typos or incorrect information provided, or just easy information. So we will create a measure or score of how similar the records are, and then using that score, all the pairs of records that are identified as similarity candidates will be recorded, and we will report them as high scores and matches according to our locality sensitive hashing function that we're using. So what can this hash function be? So we mentioned that what we're comparing here is the first one is their name, second one is their address, third one is their phone number. So we could have a function for each of these rows. Compare if records are identical in at least one of those. And again, our very simple function is just if they match or if they don't match. So we're looking for 2 ones. This means if these 2 people have the same phone number and the same name, then they are probably the same person. So compare if records are identical on one of those. If there's small differences or some typos in the fields, then it's going to miss that. If we want to have one bucket for each string, we can sort the strings. And put the same strings in the same bucket. So that's one application of this locality sensitive hashing function. Another one is that we can find similar news articles. So let's say the problem is we have the same article from some publishing company. Associated Press appears on the website of many newspapers, but looks different in the different newspapers. So we have the problem of identifying duplicates online news articles. So we can use this locality sensitive hashing function that we have seen to determine that. So we can create candidates of articles of similar length. We can do bin hashing, and we will be able to determine, let's say, news articles that are, let's say, 80% similar to each other. So there was an experiment was done with this, and the results of this experiment is that using this locality sensitive hashing function and link hashing, we were able to identify like 80% of similar news articles. The issues that are faced with that is the fact that this has to be done row by row. We use these similar rows because typically those vectors will be expressed as columns and not as rows. And so we need to make sure that we're using the row by row comparison. Because usually it doesn't look like that. Usually the data is, if we're going to compare, let's say attribute 1 is here, attribute 2 is here, attribute 3 is here. And then you have some customers here, and then they have values. Then these vectors will be, for let's say for x1 and x2, they differ on A. So they have 1, 0. On B, they are the same. On C, they differ. And on D, they differ. So these actually came out as rows and not as columns, because most of the data is like that. So they have to be flipped from row to column. there are some issues with the type of vocabulary that is used in those specific news articles. So news articles that have a lot of stop words, others do not. And if that's the case, then a stop word can be used as a shingle. If we do that, some bias can occur because we will pick more shingles from an article that has more stop words than an article that does not, such as advertisements. And so the particular vocabulary of those documents have to be considered when we're doing these comparisons. So we pretty much need to consider a dictionary of type of words that is used for the documents that we are considering. A dictionary of vocabulary for those ads and news articles. So pages with the same article but different ads have higher geographhic similarity than those with the same ads but different articles. So that was what this experiment concluded. So in summary, this locality-sensitive caching can be used for comparing large set of documents that can be text documents or records of customers or descriptions of other things, genetic sequences of some medical exams of whatever the data is. So you can compare large amounts of documents and determine if they're similar to each other by placing them in the same bucket. These can also be used for clustering in terms of calculating the similarity measure between documents.